Okay, let's take a quick look at transformations of exponential graphs. So exponential graphs, we know that there's a number of features for them for the parent function, like y is equal to 3x. We know that the y-intercept at 0, 1. We know that one of the points is 1, 3. We know that the x-axis, y equals 0, is the asymptote. So we need to know those basic features. And then what happens when we slide the graph right and left and up and down, because we can. So we know that our transformations remain consistent. When we apply something to the x, we're going to be moving the graph right and left. Yeah, right and left. And we know that we're going to be moving the graph right and left opposite to what we put in the equation. So for example, if we want to move the graph to the left one, right, to -1, then that is looks in the equation as +1, right? So left one goes into the equation as +1. -2, for example, if it's a slide to the right 2, then that goes in as a -2, right? And so we need to make sure that we understand that whatever the slide is, if it's to the right, then it's going to be -2 or a negative value. If it's to the left, it's going to be a positive value, always the opposite to the actual move, right? So that is a slide to the right and left when we apply a slide of A. So let's take a look at what it looks like when we do a vertical slide up and down. Well, again, if we add something here, just like we did with parabolas and cubics, then a slide or a change of B is going to slide the graph up and down. And it's not going to be opposite, it's just going to be, so we slide it up 1, it goes up 1. And so the new y-intercept for parent, to the parent function would be, if you're going to add 1, then we're going to be at 0, 2, right? Because the y-intercept starts at 0, 1. So all the points just move up by 1. If we go down 1, then we're moving down at 0, 0, basically, is where our y-intercept will be. Now, there's something happening. There's this purple thing that's kind of following me around as I move the graph up and down, right? So hopefully you understand that that is the asymptote, because the asymptote is the x-axis initially in a parent function, but as soon as we do any kind of vertical slide to the graph, right, anytime we're going to do a vertical slide, we're going to move the asymptote up as well. So when we have a slide that's up 1, right, then that plus one is going to tell us where our new asymptote is. It is at 1. So we have to make sure that we're very comfortable around the idea that as we move the graph up and down, the asymptote is also going to move up and down with that slide, right? So not only do we slide the graph up and down, but when we slide the graph up and down, just like a hyperbola, that means that the asymptote is also going to move. So that's really all there is to slides up and down. And I mean, we can have combinations of these, and we'll have to understand what combinations of these will mean to to what we're talking about. So if we have a combination move, how do we come up with an equation for a combination move? Because how do we know if it's moved up, right, left? And so that's the next thing that we're going to do. We're going to take a look at what happens if we have a combination of moves and how do we come up with the equation. But for now, we just need to make sure that we're comfortable with what A and B do.